Miscellaneous examples. A car starts from a point P at time t equals to 0 seconds and stops at point Q. The distance x in meters covered by it in t seconds is given by x equals to t square into 2 minus t by 3. Then find the time taken by it to reach Q and also find distance between P and Q. Solution. Let v be the velocity of the car at t seconds. Then v equals to dx dt, which is equal to 4t minus t square. Thus v equals to 0 gives t equals to 0 and or t equals to 4. Now v equals to 0 at P as well as at Q, and so at P t equals to 0 and at Q t equals to 4. Thus, the car will reach the point Q after 4 seconds. Also, the distance travelled in 4 seconds is given by the value of x at t equals to 4. Putting t equals to 4 in its equation, we get the result as 32 by 3 meters. A water tank has the shape of an inverted right circular cone with its axis vertical and vertex lowermost. Its semi-vertical angle is tan inverse 0.5. Water is poured into it at a constant rate of 5 cubic meter per hour. Then find the rate at which the level of the water is rising at the instant when the depth of water in the tank is 4 meter. Solution. Let R, H and alpha be as shown in the figure. Then tan alpha equals R by H. So alpha is equal to tan inverse of R by H. But alpha is tan inverse of 0.5, which is given. So R by H equals 0.5. Let V be the volume of the cone. Then V equals 1 by 3 pi h by 2 whole square into h, that is pi h cube divided by 12. Now differentiating it with respect to t, we get dv dt is equal to pi by 4 h square into dh dt. Now rate of change of volume, that is dv dt, is 5 meter cube per hour and h is equal to 4. Using this information, dh dt is equal to 5 by 4 pi, that is equal to 35 by 88 meter per hour. Thus, the rate of change of water level is equal to 35 by 88 meter per hour. Let us take an example. An Apache helicopter of enemy is flying along the curve given by y equals to x square plus 7. A soldier placed at 3,7 wants to shoot down the helicopter when it is nearest to him. Now find the nearest distance. Solution. For each value of x, the helicopter's position at a point is x, x square plus 7. Therefore, the distance between the helicopter and the soldier placed at 3,7 is root over x minus 3 whole square plus x square plus 7 minus 7 whole square, that is under root x minus 3 whole square plus x to the power 4. Therefore, fx is equal to x minus 3 whole square plus x to the power 4. Now differentiating it, we get f dash x equals 2 into x minus 3 plus 4x cube. It can be written as 2 into x minus 1 into twice x square plus twice x plus 3. Thus, f dash x equals to 0 gives x equals to 1 or 2x square plus 2x plus 3 equals to 0, for which there are no real roots. Also, there are no endpoints of the interval to be added to the set for which f dash is 0. That is, there is only one point, namely x equals to 1. the value of f at this point is given by f of 1, which is equal to 5. Thus, the distance between the soldier and the helicopter is root over of f1, that is root over of 5. Note that root over 5 is either a maximum value or a minimum value. Now, since root over of f0 is equal to root over of 0 minus 3 whole square plus 0 raised to the power 4 is equal to 3, that is greater than root 5, it follows that root 5 is the minimum value of root over of fx. Hence, root over of 5 is the minimum distance between the soldier and the helicopter. Example: if the radius of a sphere is measured as 9 cm with an error of 0.03 cm, then find the approximate error in calculating its volume. Solution: let r be the radius of the sphere and delta r be the error in measuring the radius. Then r equals to 9 cm and delta r equals 0.03 cm. The volume V of the sphere is given by V equals to 4 by 3 pi r cube. dV dr is equal to 4 pi r square. Now dV equals dV dr into delta r, that is equal to 4 pi r square into delta r. The answer comes out to be 9.72 pi centimeter cube.